And according to my schedule, we have half of the class time to finish up chapter 1, and then the other half of the class time we go to chapter 2. So we're going to hurry through this stuff, and if we don't talk about everything, you're welcome to send me an email with a question or bring a question up when you come to class. But it says on page 17, describing the earth. Somebody wrote on their comment on the discussion page on Canvas that it was interesting that the earth isn't a perfect sphere. That it's a little bit out of kilter. They thought that was just an interesting piece of information. Mm-hmm. Just like the earth rotating around the sun doesn't form a perfect circle. It's elliptical. Now you say, well, I know that because in my science book they always show a big ellipse. No, it's not that big. They're doing that because they're trying to show 3-dimension on a flat surface. If I were to draw you a picture of the way the earth rotates around the sun and drew it exactly to scale up here on a flat surface, it would look round. So it's a little bit out of round, but not that much, not as much as some of the books show when you look at them. Because see, books, just like these maps distort things, books distort things because they're trying to show 3 dimensions. So when they take a circle, can you see what happens? You take a circle and you tip it like this, and all of a sudden it becomes an oval on the page. So watch out when you see those books with those big ovals, because it looks like the earth is going way out here and coming back around close, and it's not. It's pretty much close to a perfect circle. But anyway, on this description of the earth, the one thing they left out is how fast we're moving. How fast are we spinning?
Fast.
There's a picture on the internet. You can Google Earth stuff, or you can go Google things about. You could just Google Earth rotation, and there'll be a picture of it, and it looks like it's going to go. Say, whoa! It's not spinning that fast. It's going over 1,000 miles an hour. Whoa! You go, if I got on a merry-go-round and spun it 1,000 miles an hour, it would throw everybody off the merry-go-round. You've played that game where someone spins it and tries to throw you off? It would throw you off the merry-go-round. Say, yeah, but see, we have gravity holding us on here, and we're a very big merry-go-round. What's it say on page 17? Gotcha, Adrian. What's it say on page 17 about the circumference of the earth? 25,000 miles. And why don't these globes show the actual elevations of the mountains? Well, yours can't because it's this one, but this one, if you put your hand on it, it does have little indentations where it shows, okay, they've raised the surface. You say, but they haven't raised it that much. But think about it. You here to take a test? Mm-hmm. Well, I happen to have one for you. Right. Have a nice time.
You going back today? You go back tomorrow.
So, because see, it says the highest point above sea level is 29,000 feet. Well, how much would that be? 29,000 feet is like 5.5 miles. Okay, that would be on this little globe. If this little globe were scaled down from, like the Earth is 25,000 miles around, and this is only like 38 inches around. So if I scale down the height of the mountains on this little globe here, they would be 8 thousandths of an inch tall. So this planet, this big blue marble that we live on, when they show pictures from out in the space station, this big blue marble we live on, they're a long ways away when they're taking those pictures, and that's why it looks so small. But we live on one huge big blue marble. Okay, and that's from page 17. And did all of you get my announcement about there's a book in the library on reserve if you don't have a textbook yet, so you can go over there and get your reading done? And did all of you get my announcement about sending me an email after you've read the syllabus? Good. Okay, so let's get that taken care of. So, what is it about this globe description that's really interesting? You go, oh, I don't know. Well, let's get your one out that's there on your table. And there's a couple of extras. So, if some of you want to have two of them, he doesn't need one, do you?
No.
You want two? You want one for each of you? There's another one. Okay, looks like you guys will share. So let's take this little globe on page. I'm looking at page 18 where it talks about latitude and longitude. Probably the best way to look at this is go to the equator. See where that is, right in the middle? Does it say equator? Okay, go over where you see the United States. I better stand back here so the people online can see this. And then just start going up. 1, 2, 3, 4. I'm counting these little blue lines. 5, 6, 7, 8, 9. So each of them is 10 degrees, because all the way up to here would be like a 90-degree angle. You follow that? So where is Kansas City? How far north of the equator is Kansas City? 10, 20, 30, almost, see where Kansas City is on that globe? It's almost 40 degrees. Now, what is that? 40 degrees north, because we're going north of the equator. And what is that called? Latitude. 40 degrees north, latitude. Okay? Now, let's go out here to, let's go left. Follow that latitude 40 and start going out, and what's the next big town you run into? Denver. Okay, if Denver and Kansas City are close to the same latitude on the globe, how come it's so much colder in Denver than it is in Kansas City?
It's elevated.
Anyone know elevation? That's exactly right, elevation. You know how high Denver is called the Mile High City? That means they're 5,000 feet above sea level. Does anyone know how far Kansas City is above sea level? Well, if you Googled it and said, how far above sea level is, or what is Kansas City's elevation? I think you'll find it's something around 1,000 feet, or like a fifth of a mile. So, do you understand? If you go out to Denver, you go, hey, I'm at the same latitude, so if I go out to Denver, it'll be the same climate. No, because Denver is 4/5 of a mile higher in the atmosphere than we are. And the further you go up in the atmosphere, the colder it gets. Okay? Let's go over here to, where's the next town on your little globe that's close to 40 degrees latitude? Reno? Does Reno, Nevada have weather like Kansas City, Missouri? No, because I wonder what their elevation is. I didn't look that one up.
4,506.
4,000 feet?
Yeah.
That's almost close to Denver, isn't it? So let's go the other direction. Let's see, who's going the other way from Kansas City?
Little Rock.
Little Rock?
Wait, do you mean south or east?
On the latitude, on that
Oh,
40
east.
degrees north latitude.
Or
You really wanted Little Rock.
Cincinnati.
Cincinnati's up there?
In Indianapolis,
Indianapolis?
Columbus.
Well, let's go across the ocean. See what foreign country is at 40 degrees north latitude. Madrid, Spain. Do you see that on there?
Mm-hmm.
What's the elevation for Madrid, Spain? Someone who likes to Google stuff real fast.
2,188.
How much?
2,000.
2,000? So I'll bet Madrid has a climate close to ours. Oh no, maybe not. Because, what's the difference? Here's Madrid, and look at Madrid and draw a circle around, a big circle around Madrid, and they're surrounded by a whole bunch of water. And go to Kansas City and draw a circle like that, and we're surrounded by a whole bunch of land. So that's going to make a difference in the climate as well. So let's go back to Madrid. We're at 40 degrees north latitude, and let's see where we end up next. Down and chopping off the toe of the boot of Italy, going through part of Greece, Turkey, Turkey's kind of, the whole country's kind of right around the 40th degree north latitude, isn't it? I don't know who this Turkmenistan is. They sure got a lot of stands over there, don't they? Kazakhstan, Uzbekistan. Let's go back over here to where Turkey is. And let's go from 40 degrees latitude north to 50 degrees to 60 degrees. Whoa. What country is right on the line at 60 degrees north latitude? St. Petersburg in Russia. Do you have an idea what kind of weather they have in St. Petersburg? Okay, let's come back to America. Stay on 60 degrees north latitude and start going to the left.
Hit Canada.
Whoa, that's touching the tip of Greenland. That's the northern part of Canada. I don't care what anybody says. When you get that far north in Canada, what? It's just plain cold up there. So when you are talking to people who live in other parts of the world, you see where it kind of helps to look at what latitude are they on, how far north of the equator are they, or how far south. And does that explain something too? Because here we are up here. If we go 40 degrees south of the equator, there's 10, 20, 30, 40. We've gone beyond Australia. Australia doesn't even come, Australia is, most of it is 10 degrees closer. Well, here's 10, 30 and 20. 30 and 20, most of Australia is right there between 30 and 20 degrees south latitude. So no wonder they're having all those, what is that they're having? A drought? Because it's been dry in that part of the world. They're not getting much rain. Well, this year people are, I think. I saw some pictures about weather on the internet showing the desert out in Arizona flooded because of all this rain we've been having. Okay, so that helps you. While we're here looking at this, talking about this latitude. It shows pictures on page 18 to help you understand it. Let's flip back to that map back at the front of your book here on page, is it page 4 or 5? No, it's page 8. Page 8 and 9. Now look at page 8 and 9 and then hold up your little globe. And which is more fun to look at? Yeah, the globe. The globe's a realistic picture of what's going on. So for those of you who are taking this class because you're going to be teachers, you need to get these things and have them in your classroom so the little kids in your room don't think the earth looks like it does. I mean, looking at page 8 and 9 makes you go, oh, that's disgusting. But they can't show the 3 dimensions there, so you have to bring it to class with you by just buying these little globes. Okay, the other thing on page 18 talks about is the prime meridian. Does your globe show the prime meridian? Well, do you see anything that says prime meridian? Isn't that something? Everything but. It's not on yours, is it? Well, then let's look at mine, see what my other little globe says. I know the prime meridian goes through England, so I go over here to Europe and look to see. Oh, there it is. See that? Can you see that big, bold, black dotted line? Prime meridian. The meridian, does everybody see that on here? So where would that be? Oh, wait a minute. I think we can figure out how to do that. Look at your little globe here and go around to England where, go to the equator. Can you see those numbers?
It would be this one.
It's hard to read those numbers. But can you see the prime meridian is where it's going to be when they're going east and west from the prime meridian. It'll be so many degrees east of there or so many degrees west of there up to 180 because it stops on the other side. Instead of going all the way around, it just goes from over here around 180 and this way around 180. I guess your textbook shows a picture of that on page 18, so that helps you see that. But why does the prime meridian, I mean, what did this globe call it? It called it the meridian of Greenwich, England. Why does the prime meridian go through England rather than through New York City or through Kansas City? Can you believe at one time the French had the prime meridian going through Paris? And the Spaniards had the prime meridian going through their country? So who cares where the prime meridian is? Well, if everybody in the country, in the world, is going to talk about where they are on a boat in terms of how many degrees latitude or longitude, degrees east or west of the prime meridian, we have to have some place to start. And in the 1800s, they all got together, or at least enough people did who were influential, and they decided that the prime meridian would go through Greenwich, England. And I think they call it Greenwich Mean Time on page 19 because England had the best clocks, and they're using the principle of clocks to measure distance around the globe. And I think it's interesting on page 19, excuse me, that it says that the prime meridian is at 0 degrees longitude, and it's designated as Greenwich Mean Time. And the Earth as the Earth rotates eastward, the clock advances 1 hour for each 15 degrees traveled east of the prime meridian. So we're using that for time because this thing is clicking around. By the way, I told you what, it's spinning around at about 1,000 miles an hour. Look, maybe close to 1,400, but it's over 1,000 miles an hour. But it takes 24 hours because it's so big, 25,000 miles around there. It takes 24 hours for it to go all the way around. So do you follow that? That kind of puts it in perspective when you see what's going on. The guys out in space who look back at the Earth, they get to see some of that rotation effect. And can you see, because it's so big, it doesn't look like it's going that fast. And you can Google pictures of Earth from the space station and see all kinds of cool things out there. Thematic maps. On page 20. Do I have time for this? Maybe I do. Do I have enough of these in here for all of you? Yeah, do I have enough of these? One for each table? Open this map up and see what you think. This is one cool map. What kind of map is this? Well, can you tell from the front of it?
Missouri.
It's Missouri Department of Conservation. So it's got a whole bunch of little orange squares on it. Someone pick an orange square just for fun. Pick one and give me the number on it.
D31.
D31. So someone just looked at D31. Now here's how you find it. Turn your map over. Look on the back. I'm going to give you a little lesson in map reading. Look up D31 on the map and tell me what it says.
Doris Creek Prairie.
What?
Doris Creek Prairie.
Doris Creek Prairie? What's it say about it?
4 miles east of Highway 71, then 1 mile south on Southeast 40 lane.
It tells you how to get there.
Wow.
And then what else does it say about it? Which one are you looking at?
D31.
D31. Where'd it go? Here it is, D31. What else does it say about it? F, SH, WH, BH. You know what F stands for?
South.
Well, see up here in the corner on your map? F stands for what?
Fishing.
Fishing. What's
That's what you
SH
said,
stand
guys.
for? What's SH stand for?
Hunting for how do you say that?
What's WH stand for?
Hunting for a waterfowl.
That's duck hunting. For those who didn't know, waterfowl were ducks. What's BH stand for?
Where's the 12 gauge?
Hunting for deer and turkey.
What?
Hunting for deer and turkey.
And what's E7 stand for? Okay, turn your map back over and go across the top to E. A, B, C, D, E, and down on the left-hand margin, down to 7. Do you see it? Yeah, you do, because you were the one who picked it out. Let's see if somebody else can find it. What did it say? E7?
I see S64.
Looking for D what?
31.
E7?
D31.
Easy.
Yeah, D31. Do you see it?
I see D25.
Where's D25? I see D18.
31.
No, we're looking for D31.
Where's 7 again?
It's west from D25.
Oh, I'm not going far enough south.
Woo! Found it!
Did you find it?
This?
Yes.
What is it, D31?
Mm-hmm.
There it is.
No, this way. Come towards me way.
You have to go clear down to,
Found it.
Geography class is so fun.
Why
where?
would you pick one not in the
This
middle?
is where they.
Why would you?
Almost to Carthage. Can you believe that every one of these little orange squares is a conservation area maintained by the Missouri Department of Natural Resources? And if you look on the back, most of them have fishing on them, and many of them have a boat ramp, and they're all public. There's no fee. They don't belong to any private person. They belong to the state of Missouri, and anyone with a fishing license or a hunting license, or if you want to go hiking, it's a public use area.
That's right.
Most of them have restrooms built there, and they're maintained by the Department of Conservation. This is what's called a thematic map. And I used to give these away because they're such a cool map. But guess what? The Department of Conservation quit making them. And I don't know if they're ever going to start doing it again. So guess what? I have to have them back.
Hog season coming up.
What season?
Hog.
But that's okay, I'll hold it. Most of the
What's the
stuff,
cost of hog?
most of the stuff, in fact, all the stuff on this map,
I'm not eating that bird.
you can find on the internet at Missouri Department of Natural Resources. No wonder they don't like maps anymore, they're hard to fold.
I agree.
You have to hold them outside, flip them just right, get them to fold up for you. All right.
We need to go
Good. So I have to take these back. Do I have them all? Good.
Yes, you are.
So I'll have them for the next
You got
time I
flying
teach
trees.
geography. Okay, that's a thematic map. On page 21, it talks about
Well, if you get bit a couple times.
topographic maps. Let's go down here.
Goes. You'll be able to climb a tree.
Belton.
You hear the scream coming at you. That's when you'd be like, oh Lord.
Topographic map.
Time to go.
What's going on here? How come it quit on me? Belton. Topographic. Oh, I spelled it wrong. Belton. T-O-P-O.
For sure, stop it.
Graphic map. Let's go see what happens here. Belton Lake Topo map. Images of topographic maps. Okay, now see, there's a whole bunch of things. If you did this on, oh, you don't have it on. You can't see what I'm doing. Just tell me when I don't turn this thing on for you. Okay? I'm sitting here thinking they're watching me do this, and you're not. So when I do that, just say, you have to turn on the camera so we can see what's going on. While I'm holding up the globe here, no, we'll save that for later. we'll save that for later. Let's get this thing going. Does anyone remember what I typed in for my search word? Belton topographic maps. And then I scroll down to, now it just happens that I've checked a number of these out. So I scroll down to pick a trail because that's the coolest one out here. So I went to the one that had pick a trail on it, and then I came down here and said, whoa, let's pick which one? About where we are, that would be number 5. And then let's come down here and see what happens when I click on this one. Open. Is it going to pop up there? It's going to take a little while to get there. Okay, we'll just let you use whatever you want to use to open it. Ah! Cool. I don't know if you can see that or not. But there's 71 highway. Can I make it bigger? That helps a little bit. Now see, if you had this on your own little laptop or like at my home computer, when I click on this right there in the middle, where is it? Somewhere about right in where? Somewhere in here is Calvary Bible College. Or Calvary University. And see all those little lines? All these little lines on here? Squigglies? Those are elevation lines. And if you ever go hiking on a trail somewhere, at the top, at what they call the trailhead, always get one of the little maps that shows one of the topography maps that show the elevations. And I'll tell you why. Years ago, when our granddaughter was just a little baby, her parents wanted to go take a trip into some of the hiking trails in Missouri, and we were hiking around this trail, and this little baby got to feeling uncomfortable, and so my daughter said, maybe we better go back to the car. And said, well, if you follow the trail, it goes around this mountain, and that's about as far as if we turn around and go back. That'd take as long as we've already gone. But according to these lines here, the closer the lines are together, the steeper the incline. The parking lot is right up at the top of this mountain that we're walking around. So why don't we just climb up the side of this mountain? I mean, it wasn't a steep climb. There is no such thing as a steep mountain climb in Missouri. So let's climb up the side of this mountain, and we'll be at the parking lot, and we can go right to the car. And when we did that, my daughter goes, my granddaughter was a little baby. My daughter goes, how did you know that, Dad? And I said, because I know how to read topographical maps. I've looked at them. So it might do you well to, if you like to hike, do some looking at topographical maps, because what it does, it shows here on campus that our campus is kind of up on this hill, and then it has all these lines going down where over there where they do that sledding, that real steep hill, the lines are real close together. Someplace else they're further apart because it's showing those are elevation lines. So it gives you, once you learn how to read one, it gives you a sense of the lay of the land, what kind of elevation you have there. And that's just a fun thing to look at, but see, it's not magnified enough for you to really see the whole thing, which is too bad. But on my little computer screen at home that's about this big, because it's easy for me to see it, I can blow that thing up and see all kinds of neat things on it. Okay, so you've seen a topological map, you've seen a thematic map, and where are we here? It's just about time. Thank you. It's just about time to finish this chapter. On page 25, it talks about geographic information. Global, and on page 26, it talks about global positioning systems, where all of you have a GPS. That's what GPS. All of you use GPS to get around. Well, you know how it works, don't you? Well, you say, no, I just use it. Well, the book's telling you how this stuff works. There are all these satellites out there that your GPS little thing is connected to, and it tells you where they are. And they've used all these satellites to map out the whole world. And it's amazing what you can find on the internet. In fact, some of this stuff, I've been uploading some of it to my Twitter account. So if you want to just take a tweet someday over spring break and look at a whole bunch of geography stuff just for fun, it's there. So they explain GPS, and then on page 28 it talks about GIS. I get this magazine at home, and my wife goes, "What is this, Tom?" I said, "It's the GIS magazine. It's the ArcGIS magazine. It's an organization," and you can see the picture on page 29, how complicated it gets, how they build all these layers of stuff. But they're using satellite technology to do all kinds of things. Just like now, when they've had these hurricanes in the Gulf Coast, the GIS people have told them what's the best way to evacuate people, and what kind of problems can you encounter. They can put all this in a computer and do all kinds of computer analysis. Probably the people in New Orleans who live where, if we keep suffering from global warming, according to what the scientists are telling us, the icebergs are going to melt, the ocean's going to rise. Okay, does anyone know anything about New Orleans already? New Orleans is already underwater. The way they keep from flooding is they have pumps going all the time, pumping the water back into the Gulf of Mexico. That's crazy. So my solution, and of course if the ocean raises another 2 feet, they're in big trouble. So what do you suggest people in New Orleans do? Move to higher ground. Just pack up the whole city and move north. But if you tell that to people who live in New Orleans, they go, "No way. My family's been living here for generations." And I'm saying, well, yeah, but guess what? The climate's changed, and they're going to get washed out. They're going to get flooded. And you can't buy enough pumps to keep all the water out. I guess you could build some dikes and make it higher. But the higher you go, the more when there's a storm, the more you're going to suffer, or if your pumps fail. So it's just a matter of, hey, we're probably eventually, not during my lifetime, but by the time you're old people, who knows, they'll be packing up New Orleans and moving them up north to another part of Louisiana. But this GIS stuff, I mean, when you read through it, it might be a little overwhelming, but don't worry about it. Just read it and just pick up what you can from it. Remember, part of the reading assignment is worth so much because I just want you to read every word on every page, just so you've kind of caused yourself to look at all this stuff. And granted, this book uses a lot of technical language, but whenever you come across something that's very technical and you say, "I don't know what they're talking about," just Google it. Just Google it, and you'll find some cool stuff to look at. Okay. So I guess that takes care of chapter 1. So let's start chapter 2. Now, if I missed something in chapter 1, you say, "You know, I was wondering about this." Then just go ahead and say something to me. Send me an email or say something in class, and I can always go back and talk about it. So what are we doing in chapter 2? Well, I have a couple of discussion questions. On page 38, it talks about, where is it there? Atmospheric circulation. on page 38. In the process of air and water on the left-hand column, moving from one place to another, weather is created. Did you know that? And that movement of air and water is called atmospheric circulation. Have you ever been sitting on a beach next to a large lake and noticed a breeze when the wind wasn't blowing? You go, no, I don't think so. Okay, have you ever been sitting next to a lake and when the sun starts going down, you start feeling a little chilled because it feels like the wind's blowing? Well, guess what's going on? When the sun's shining bright, the water is hotter than the land. So air is blowing from the land to the water. And if you were out on the water, you would probably be a lot hotter than you are right on the shore because the air is keeping you cool even if you don't notice it. Just a little bit of wind that you can't even notice will keep you cool. Then when the sun starts to go down, then what happens is all of that hot air from the lake going up and bringing in from the side, it's just like it starts to cool down. And it can even get cold enough to where it can change and go the other direction. And then the water that was really hot can turn to get pretty chilly, especially if it's a deep lake. And then you start feeling a cool breeze off the lake coming back to the shore where it starts to make you chill. Basically, that's what's going on with atmospheric circulation. If you live on the edge of town, right on the city limits, on the outskirts of a town, well, for example, Kansas City. I used to live in one of the suburbs of Kansas City, and I was kind of right on the edge. It's kind of like where I lived was like a dividing line between the city and nothing but farmland. So when the sun's shining, the city with all of its concrete gets heated up and the heat rises and draws in cool air from the outlying surrounding areas. So by living on the edge of the city limits, I could actually open my windows in the evening on a hot summer day and get a cool breeze coming across the farmland being drawn into the city because the hot air was rising. That's what it means by circulation. It's the same with water. It's the same kind of thing that happens in the ocean. But probably here in Kansas City, you're going to have more experience with air circulation than you are water circulation. Probably the best thing to learn about water circulation is that if you don't know what a riptide is, it'll rip you off. It'll really tear you up. So you better learn something about oceanic circulation before you go to the ocean, and then be careful when you're there because it can be dangerous. On page 39, so this process of air and water moving, for us in this part, it's the air moving that cools things off. And in fact, if you're standing someplace where it's really hot, because maybe you're just out in a park and you're in an enclosed area where it's hot, you say, hey, there's a little breeze out there. You can see the leaves blowing or the grass blowing. If you move your chair out where the breeze is, it'll feel cooler. So that's the idea of some atmospheric circulation. And let's see, maybe we should just go back and Google this. Let's go Google. What am I going to Google? Atmospheric circulation. ATM. Need to turn this back on. Just tell me, turn it on, turn it on.
Turn it on.
Turn it on. ATM. OSPHERIC. Atmospheric, what did we say? There it is. Atmospheric circulation. And I looked over a bunch of these. Here's some cool pictures of atmospheric circulation. Images. But see, if I clicked on those images, they're so small up there, you won't be able to see them. But let's go back to this one from Atmospheric Circulation, Wikipedia. It talks about it. And then it shows some pictures of it. Of how, this is how, if you're sitting out there in that space station looking back at Earth, this is how you see the wind blowing on the Earth. You go, what? Yeah. And any idea why they have this thing called a Hadley cell? Because a guy named Hadley, a scientist named Hadley. I mean, why is it called Newton's law of gravity? Because a guy named Newton figured it out and told us all about it. So that's what happened with this circulation stuff. And this circulation stuff can get really complicated. Let's see, what do we have down here? Do we have some that say images? Videos of atmospheric circulation. That sounds good. No, that's 11 minutes long. We don't want to do that one. There was one. Where'd that one come from? Where'd it come from? I don't know, but I sure wish I had it. Oh, wait a minute. Atmospheric circulation. Maybe go up here and put atmospheric circulation images. Whoops. Images. See what we get there. Oh, yeah. That looks nice. Let's click on these images and see what we come up with. Oh, there's one. Pulsing away at you there. Atmospheric circulation videos. Let's try videos. On YouTube. Yeah, that's what I want to do. Is that the one I want?
You're still on pictures.
What?
You're still on pictures.
Well, I saw one the other day on my computer at home. It was really cool. But it was only about 2 minutes long. No, that doesn't seem to be getting it. Let's go back and look for something else. see it here on Bing.
You're on images only. so-
Which one?
You're on images only. You'd have to either go to videos or all to get videos.
Oh, I see that
You
now.
click on videos
So-
right by the
See up there,
image.
like the
Up
little red
top.
line, right underneath the atmospheric.
Where do I click? Show me what to do.
Okay, so you're in images only, so
Oh.
you need to either click videos or all.
All right, so I need to go to videos. Thank
There
you.
we go.
All right, let's see what happens. See if I can see the one that I saw at home. I don't see it on here. That's too bad. That was a good one that I found at home. It was about 2 minutes long, and it showed how. Is that it? No. Well. That's 22 minutes. I don't want to watch one of those. I had one for 2 minutes long. Here's one for 4. What's this one? 3? Oh, that's air pressure. Well, let's see what happens. What causes atmospheric circulation? Well, that's kind of nice. So do we have the speaker going? It says it's on. Maybe it's not on here.
Pay attention. Pay attention. Pay attention. I'm trying to concentrate.
Where'd it go?
Are these speakers on?
I thought they were. I clicked on them down here and it said they were on. Huh. Well, there's some cool videos out there that show pictures of atmospheric circulation. So just get on your computer and find them. And I'm sorry they're not turning up today, but we'll just close that all down and shut this off and keep moving. I think what happens is my computer at home uses Chrome as a search engine, and this computer uses Bing. So I'm probably going to have to start using Bing so I can figure out how to find some of my stuff on Bing. On page 39, it talks about solar radiation. Do you know what insolation is? I-N-S-O-L-A-T-I-O-N. You know what insulation is, don't you? I-N-S-U-L. That's stuff inside your coat that keeps you warm when you go outside. Or stuff you put in the walls of your house to keep it warm. Well, this is insolation. And it says on page 39, it depends on 2 factors. Solar intensity and the number of hours during the day that the sun shines on your house or on your place or on your person. Let's see if we can find this one. So, you understand how hot the sun is? Have you ever been sunburned?
Yes, sir.
Then you don't understand how hot the sun is. Or else you would have gotten that. No, I knew it was hot and I knew I was going to get burned, but I stayed out there anyway. And the sun can really scorch you, right? And here in this cold weather we're having, my grandson had a baseball game the other day. I went to watch him play baseball. I put my chair to watch him kind of underneath an overhang where it was shady, and I started getting cold. So what did I do with my understanding of insulation? I moved my chair out into the sun, and got toasty warm all of a sudden. And then pretty soon the sun starts moving and I'm in the shade again. So I just pick up my chair and move it over into the sun again. It wasn't as good a spot to watch the game, but given a choice between being in the best seat to watch the ball game and being comfortable, any idea which option I went for?
Comfortable.
You bet you got that right. Comfortable. Okay, let's type something in here. I'm sure this is going to work. Sunrise and sunset calculator. Sunrise.
Dr. Bowen,
Uh-huh.
we can't see it.
It's
Oh.
on again.
What did I do? I don't know what I did. Oh, maybe I hit the wrong button. Computer. I want the computer. Video. Computer. There. That's what I want. Is that it? Yeah. Good. Thank you. I just hit the wrong button a while ago. Sunrise, and what else do I want? And sunset. Sunrise and sunset calculator. This is so cool. If we find it. Kansas City. Yeah. See what we get here. Can you see that little picture up there? These are days of sunlight. It looks like in July there's a lot more sunlight than there is in December and January. Any idea why it's got these two broken areas?
This is daylight saving.
November and March is when we flip to daylight savings time, so it joggles the graph. Now, I don't know how well you can see those numbers on there, but this is so, can you see? Let's go to where we are right now. Okay, it says that there's, where does it say? Okay, can you see that right there? That there's 9 hours of darkness and 11 hours and 50 minutes of daylight. Can all of you see that on there? And if you can't, you can take your little tablet and type in there and find it. And watch what's going on here. Let's go up here and just move this over to March, April 14th. Well, let's go back to March. What is it? March what? What's today? 13. So here's March 13, and there are 11 hours and 50 minutes of daylight. Here's March 15, and there's 11 hours and 55 minutes of daylight. So every day we're getting 2 more minutes of daylight. That means in a month, 2 minutes per day for 30 days is 60 minutes. That means in a month, we're going to have another hour of daylight. You go, what? Well, right here, we're at March, what? 13, and it says 11:50. Let's go to April. Let's go over to April 13 and see what happens. April 13 is 13 hours and 9 minutes. So you see what's happened? We've gained, by a month from now, we'll have another hour of daylight and only 7 hours of night. Well, let's jump to the middle of summer when we're all looking for July to get here. On July 13th, there's only 5 hours of darkness and 14 hours and 41 minutes of daylight. No wonder we like summer so much. And you know what happens with little kids? What, Mom? We have to go to bed. It's not dark yet.
I've used that one.
Yeah, I've used that one. And see, you could just run this thing all the way down here. Now this is kind of cool. Let's come down to, no, let's go back over here. So watch this. There's 11 hours of night on January 16th. Then there's 11:05, 11:04, 11:01, 10:59, 10:09, 10, whoops, it went back to 9. There was 9, then there was 10:26. Okay, there's 10:30 on February 8th. On February 10th, it's 10:26. On February 7th, it's 10:32. 10:30, 10:28, there it is, 10:30. February 7th is the magic day when, what do they say? What do they say happens? February 7th is the magic day when the nights stop getting longer and start getting shorter. Because prior to February 7th, go back to January, the nights were 11 hours long. Go back to December, the nights were 11:22, and then 11:18, they were shorter. 11:07, 11:06. What happened? 10:59, 9. So where did it start? 10:52, 11:06, 11:12, 11:21, and then 11:19. 11, 18, 15, 16, 17, 10, 9, 8, 7. There's that magic place in there where it changes from getting longer to getting shorter. I think the weatherman calls that, what, the equinox or something? He's got a name for it. Okay, but that's a cool little place to go. Try to click the right button this time to turn it off. Page. Oh, and the other one is, yeah, see how the globe is tilted? Okay, do you understand that the sun's shining on the globe when it's shining, well, here we are up here in winter. So let's say the sun is a bright light in the back of the room and it's shining here and it's hitting and bouncing off. Whereas if we turn this thing around, when this is summer, see how the sun is shining almost directly on us. So because when the sun's shining directly on us, then it makes it warmer than when it hits the surface and bounces off a little bit. And that's what they're talking about on page 39 when it talks about the angle at which the sun's energy strikes the earth. Yeah, and also on page 39 it talks about the equinox. All right, page 42. I don't think there's anything else there that isn't self-explanatory. If it isn't, then send me an email or write me a note and we'll work on it. Radiation. Oh, maybe page 42. You probably should know this, that the sun's shining on the earth. Okay, so here in the summertime, the sun's beating right down on us. Okay, the earth will store heat up to 6 feet below ground. Beyond that, it just pretty much stays the same. The temperature is pretty much controlled by what's going on inside the planet. But if you have when the sun is shining on the water, water will store heat up to 33 feet deep. So can you see where if you're sitting near a lake on the shore or on the sandy beach, the water is absorbing heat up to 33 feet deep, and the land is only absorbing it up to 6 feet deep. So you see what happens when the sun goes down? The water has a lot more heat to give off than the land does, which means when it gets dark, it might have been during the day a little cold to go in the water, but when it gets dark, you go in the water because it's warmer than what it was on land. And sometimes we do that without even thinking about what's happening, but that's what's going on in terms of the way that the land and the water store heat. And page 43 talks about how heat transfers from the sun through the atmosphere to the earth. And I guess we probably ought to turn this on. And yeah, we've got time to look at one more and look at the atmosphere. Atmosphere layers. That looks like that'd be a good place to go. I'm not going to get the same stuff here that I get at home, but that's life. NASA. That sounds like a good one. Yeah. Here's the Earth. Right here is, what do they call that? Can you read that? The troposphere. And what's cool about this website is NASA tells you that the troposphere, which is about 5 to 10 miles wide, is where we have all of our weather. So when you see rain clouds coming, or when water evaporates and goes up into the clouds, and this chapter talks about this process of transfer of heat. Have you ever held an ice cube in your hand, and while it's turning into water, your hand is getting cold? Because it's extracting heat from your hand, because it's going from ice to water. If you just stood there long enough after the ice is all gone and just held the water in your hand, if you stood there for a few days, the water would, what happens if you put a pan of water outside in the summertime? It evaporates. The water would evaporate. And while it's evaporating, it would cool off your hand, because it's taking heat from your hand to go from the liquid stage into the water vapor stage, where it goes up into the air. And what does it do when it gets up into the air? It looks for other little molecules of water vapor, because they like to hang out with their friends. And the next thing you know, you see a cloud going by and you say, "Isn't that beautiful?" And then you hear thunder. And what's happened is so many little water vapor molecules got together inside that cloud that the cloud couldn't hold them anymore. And it just belches them out. That's what thunder is. And spills it onto the earth. And then it comes down and we collect it, and then we freeze it and make ice cubes and go through the same process again. But all of this stuff, all of this this troposphere, that's where all this stuff is happening. All of these, when you see pictures of life cycles and water cycles and air cycles, that's all happening right here. Now do you see why scientists are a little alarmed? Because here's this big old globe with only 10 miles of atmosphere to really keep us alive in terms of our nutrients. In fact, one of the places I found on the internet, I thought it made an excellent illustration. It said if the earth were the size of an apple, the atmosphere would be the thickness of the skin on the apple. So do you see why scientists are alarmed about the atmosphere being damaged? Because it's the thing that basically makes life livable on our planet. So it's 5 to 10 miles. Then when you come up here, it comes to the stratosphere. You see stratosphere over there? And the stratosphere, here's, okay, it's the troposphere, stratosphere, then the mesosphere. And here's what NASA says about the stratosphere. It's the ozone layer. You've heard about ozone, right?
Yes.
Remember a few years ago, there was a hole in the ozone up over the Arctic, and they were worried about that? Well, you know why you haven't heard about it lately? Anyone know why they quit making noise about it?
Doesn't it close up every
It
so
started closing up. So all of a sudden, they don't know exactly why, but there's no reason for alarm now because the hole started closing up. Maybe it's because we quit using some of those chemicals that were messing with it, but for whatever reason, it's closing up. But so what's important about the ozone? It scatters solar radiation. If it wasn't for the ozone layer bouncing off radiation from the sun, I could walk here into the Geiger counter and go and get readings from all of you. Okay? And that goes from 10 to 30 miles up. They've got it over here, I think, in meters. But that's from 10 to 30 miles up. You probably think more in miles than you do meters. And then after the troposphere is the mesosphere. Up here, the mesosphere, that goes from from 30 to 53 miles up. Or from 30 to 50 miles up. And you go, so who cares about the mesosphere? All we need is the troposphere. No, NASA says, this is what's cool about this website. NASA says that the mesosphere is where meteors burn up. If the mesosphere wasn't there, burning up the meteors that come bombarding us all the time, we would be sitting here in class and hear this chunk. You go, what was that? Oh, another meteor. Missed me, but it got your car out in the parking lot. Sorry about that. I mean, you understand what God has done to make our lives so comfortable? That's the mesosphere. The thermosphere, that's way on up here. Can you tell what's out there in the thermosphere?
Satellite.
That's where we send all of our satellites. Isn't that cool that God created all this way back when He made this world? To give us all this place where we could send our satellites, where they could be going around the earth, and you could be using GPS to find your place, find your way around. Didn't used to have GPS. Had to buy a map and then hope it was a good one. That's okay. When you use GPS, you hope it's good too, don't you? Has GPS ever messed you up? Yeah, so you have to kind of know what you're doing. And the thermosphere goes from 53 miles up to 372 miles up. And then what comes after the thermosphere? The ionosphere, which goes way up from that. The ionosphere goes from 30 up to 600 miles. And that's what we use for sending out radio waves. So there'd probably be no TV or radio without the ionosphere. God just really fixed us up here. And the exosphere goes from 600 miles out to 6,000 miles. And what happens beyond 6,000 miles? Well, did you know NASA sent a little bug out beyond 600 miles, beyond Mars, beyond Jupiter, and it's outside the solar system now, and it's still traveling out there in space? with a little gold record, just in case somebody finds it. And it's still sending back pictures. And it was launched like 40 years ago. And it's taken this long for it to get that far out into space. I mean, there's just some cool stuff that's going on. And the internet is just full of good information that helps you understand some of this stuff. Okay, and what did I do here? I put here a little piece of paper that shows you, based on the size of this globe, about how much of this, that's about 1/2 inch. So 1/2 inch would be up to the mesosphere, up to the edge, up to 53 miles, where that would be up here to the mesosphere, stratosphere, mesosphere, where it burns up meteors. And that's all the thickness we have. And of course, the part where the troposphere is, if I tried to represent that here, it would be 1/60th of an inch. I would have to take an inch and divide it into 60 units, and one of those would be on this globe, that would be to scale 1/60th of an inch would be the width of the troposphere. So is it fair to say this? We're living on a pretty fragile little bubble. So when people say we better take care of it, they're right. That little band around here that keeps us alive needs to be, we've got the wherewithal to take tabs on it, keep track of it. We need to be careful with it. And do what we can to leave the world in good shape for the next generation after us. I teach you how to read maps, and you guys go, who needs a map? See, they don't even make this map anymore because the Department of Conservation said nobody uses maps. They just go to the internet and find their wildlife area. I said, yeah, but wouldn't it be fun to have these to give to schools so people can show children all the things you do? And they go, I don't think we're going to make any more of them. But I go down there about every summer and complain and ask them to make some more because I need them. Because I can't get any more of them. They're all gone. And I used to just give these things out. It's kind of cool, isn't it, to have the whole state at a glance and see all those little orange dots? Well, time to go to chapel. Ah, isn't that right? You're supposed to tell me when it's time to go to chapel.